Okay, we got a 40-minute class today. The last lecture of the year. And tonight's homework is the last homework of the year. Okay, I'm just going to remind you, maybe I should put the camera over there. Just going to remind you, remember on derivative 1, if you want to get credit, to compute derivatives, you got to use the difference quotient and take the limit as h approaches 0. Because today I'm going to teach you a shortcut for finding derivatives, but you cannot use that until you get to derivative 2. So for those of you who didn't do your homework yet, if you do this on derivative 1, you get absolutely no credit at all. There are about 4 people to get zeros on their homework last year, just to warn you.
But you do that on derivative 2. Then
Yes, I want you to do that on derivative 2, but that's on 1. Derivative 1, you use the difference quotient and take the limit as h approaches 0. On derivative 2, you use the shortcut. Understand? Hanaoka, you understand?
yeah, we didn't have to do derivative 2 and 3 yet though.
That's tonight's homework. Remember I wrote it on the board yesterday? Again, you're just not listening. Okay, we got a lot of problems to do. We better get started then. Okay, problem 2. Say, whoa. Okay, if f of x is equal to ax squared plus bx plus c, what kind of graph is this?
Parabola.
It's a parabola. Compute the derivative. So this is the way you do it. You go, the derivative is equal to the limit as h approaches 0, f of x plus h. So substitute x plus h for x. Minus f of x. Can I just distribute that minus sign now, or just to save time? Like that? Oh, that's a minus down one. All over h. You have to form the difference quotient, and then you got to take the limit as h approaches 0. Okay, let's simplify what we got. If you multiply out the top, I'm just gonna just do this. Plus 2axh plus ah squared plus bx. In fact, this is a problem I gave you in the second quarter, but most of you just don't remember. And I bet a lot of things cancel out. So, dunga, dunga, dunga. No! Dunga, dunga, and dunga, dunga. Now, of the 3 terms that are left, can I factor out an h on the top?
No.
Yep. You get 2ax plus ah plus b all over h. These cancel out. Now, can I plug in 0 for h? What happens when I plug in 0 for h? This goes to 0. So what's left? 2a plus b. That's the derivative. Okay, now it says compute f prime of negative b over 2a. That means plug in negative b over 2a into the derivative right here. Right? This is just like regular function notation. And you get 0. What does that mean? What's the meaning of negative b over 2a in terms of a parabola? That's the x coordinate of the vertex, remember? So if you have a parabola and negative b over 2a is the x coordinate of the vertex, what is this saying? What does the derivative tell you? The slope. So that means in any parabola at the vertex, the slope will be 0. But isn't that just a duh? Whenever you have the vertex of even the doesn't matter if it opens up or down, right? The slope will be 0 at the vertex. Hanaoka.
Could we just look at the problem and say, hey, you somebody?
No.
And then draw
No,
like a
not
picture?
yet. Not yet.
So we have to like draw that.
Wait, let me look. Yeah. I told you what to do. Compute the truth. 3a and what?
Wait, you did some.
Okay, let's do 3. After that, you just want me to do plain work, don't you?
Explain the result usually.
Okay, how do you compute the derivative? Limit, there should be, do we have the difference quotient memorized yet, or we just gonna wait till Monday morning? F of x plus h, substitute x plus h into the function. Minus f of x, can I just distribute that minus sign already? Too bad I am. All over h. Now remember, anytime you do the difference quotient, it's always going to come out 0 over 0. Always. So that means you're going to have to simplify or whatever, look for friend or whatever. Okay, multiply it all out. 6x squared plus 12xh plus 6h squared minus, you guys even remember how to do x plus h quantity cube? Well, didn't you do it in problem 1a? No, because I'm just copying right now. 3x squared h minus 3x h squared minus h cubed minus 6x squared plus x cubed. Come on, 1, 3, 3, 1. Gotta learn something this year. And I bet a lot of the stuff cancels out. No, you get don't, think the don't, don't. I guess not that much. So. Limit h approaches 0, and then factor out of h in the remaining terms. Minus 3x squared minus 3xh minus h squared all over h. Oh, but the h's cancel. Now can I substitute 0 for h and get something? Yes, if I plug in 0 for h, this goes to 0, this goes to 0, this goes to 0. So what's the only thing that's left? 12x minus 3x squared. See, after I teach you what today's lesson, you're just going to be able to go from there to there. But since we're on derivative 1, you got to go through all this work. Okay, that's the derivative. Okay, now what does it say? Oh, I skipped part A. Part A is graph y equal f of x. Now, how do you graph this? How do you graph polynomials? What do you do? What's the first thing you do? Rhymes with factor. You factor it. And then, what are the x-intercepts? 6 and 0 and 6. 1, 2, 3, 4, 5, 6. And this is a cubic polynomial, so it's either going to be like this or like this. Which one is it? A or B? It's B because the leading coefficient is negative, so it's like this. So, woo, bounce off and then go through. How do I know I bounce off over there and go through there? Because there's an even power on this one and an odd power on that one, right? This is all the stuff we learned. Yeah? Okay, now we can jump to C. For what values of x is the derivative equal to 0? Well, here's the derivative. And what does the derivative tell you again? The slope of the tangent line. So I want to know, where is the slope going to be 0? That's what I want to know. Well, here's the derivative. I make it equal to 0. How do I solve this equation?
Factor.
Factor out of 3x, and what's left?
0 and 4.
What? 4 minus x. So the solutions are x equals 0 or 4. So that means when x is 0 or 4, the slope will be 0. But doesn't that make sense? Because right here, at 0, the graph bounces off, so it's tangent, right? And then at 4, that must mean this is a local maximum because the slope is 0. And then indicate the point. Well, this is 0, 0, and this is 4 comma something. How do I figure out the something? You plug it in here. So 16 times 2 is 32. 32. There you go. See, that's a good demonstration of calculus at work. Whenever you have a maximum or a minimum point, look, the slope is 0. So you go to college, you take economics, business, science, whatever. Finding maximum and minimum values are very important, and now we know how to do it. You take the derivative and you find out when it's 0. Okay, can I erase that graph? Too bad I am. Okay, next, 4 and 5. We're just doing them all. Okay, number 4. Now, first of all, you guys have to understand what's going on in the problem. Do you even understand the problem? Okay, here's the graph of y equal x cubed. At the point -2, -8, here's the point -2, -8, it says the tangent line, okay, drawing the tangent line, here's the tangent line. The tangent line will intersect the curve at what other point? So here's the curve going up like this. Oh, running out of room, it's gonna bend it a little bit. That's not how it really goes. We're running out of room. It intersects it at what other point? Find this point. What are the coordinates of that point? Now, what is the equation of the curve? Y equal x cubed. Now, here is the tangent line. Do we know how to write the equation of the tangent line? Yeah, you did it in all the other problems. So you got the point. All you got to do is figure out the slope. How do you figure out the slope? It rhymes with derivative.
Derivative.
The derivative. Now, look. Did we already compute the derivative of y equal x cubed? Yeah, we did that in problem 1a, so we're not going to reinvent the wheel and do the difference quotient again, right? The derivative is equal to 3x squared. We're just going to use that result. So therefore, what is the slope at this point here? 3 times the x coordinate squared. So if this is the x coordinate, what is 3 times the x coordinate squared? 12. The slope of this tangent line is 12. It's very steep. Can I write the equation of this line? How do you write the equation of a line if you know the point and the slope? Point slope. Y plus 8 equal 12 times x plus 2. So here's the equation of the graph. Here's the equation of the tangent line. How do I figure out where they're going to intersect? Yeah, substitution. So what do you want to do? Take that and plug it in for x there? I think that's the best way. So substitution. So x cubed plus 8 equal 12x plus 24. It's a cubic equation, make one side 0. That means we're going to have to do synthetic division. Some of you just don't like synthetic division, yeah? Because you guys don't like guessing, but we don't have to guess, because look, we already know the two graphs intersect right there. Yeah, -2, so that means -2 has to work, right? Because that's an answer. What? 1, -2, -2, 4, -8, 16, 0. So that means x plus 2 is a factor. That's because -2 is a solution. And the other factor is you look at the coefficients there. X squared minus 2x minus 8. Can that be factored some more? Yeah. You bet your sweet 50. X minus 4, x plus 2. So you got two answers. X equals -2 or 4. Now notice that -2 is a double root. Does that make sense? Yeah, because look, the graph bounces off. They bounce off of each other. Double root. And then over here, single root. See how they bounce off, they go through. That's all the stuff we learned this year. So we already know they intersect here. I want the other one. That's this one, when x is 4. How do I figure out the y coordinate? Plug it into either this one or that one. Which one looks nicer? I think that one, yeah? 4 cubed. 64, there you go. Now this is going to be on the test. Either number 4 or number 5 is on the test. You have to find where they intersect, window.
Wait, have you taught that one?
Plug it into the derivative, because the derivative tells you what the slope is. That's what the derivative is. The derivative tells you what the slope of the tangent line is. Okay, number 5. Okay, now you got the graph of y equal x squared. Woo! Y equal x squared. At the point 2, 4, right here. Now it says the normal line. Now what the heck is a normal line? Now, for those of you in physics, you should know, right? What does normal mean? Like the normal force. It means perpendicular. That's what. Anyway, don't I tell you? Look, the normal line is a line that is perpendicular to the tangent line. Normal in mathematics and science means perpendicular. Not abnormal.
So abnormal.
No, It doesn't mean not abnormal. It means perpendicular.
Not, okay. It doesn't mean
Does that make sense? Okay, here's the tangent line. The normal line is perpendicular to the tangent line again. See now look, the normal line is intersecting the curve at what other point? Right here. Because if I ask you, the tangent line intersects the curve at what other point, the answer is none, right? It doesn't intersect it at all, so that's like a junk problem. That's why you go with the normal line. Now, how do you write the equation of this normal line? Well, first, you have to find the slope of the tangent line. And how do you do that? You take the derivative. Now, I did this as an example, so we're not going to reinvent the wheel. You guys remember what it is? It was 2x. So what's the slope? 2 times the x value. So at this point, when x is 2, what's the slope? What? 2 times 2. 4. Therefore, what is the slope of the normal line going to be? It's going to be the negative reciprocal. Negative 1/4. And look, it kind of looks like it, right? Negative 1/4. So how do you write the equation of the line going through that point and having that slope? Y minus 4 equal. See, you're going to learn in calculus, everything is point slope form. Don't do y equal mx plus b. That's not good. I mean, it's okay, but it's going to take long. So here's the equation of the line, the normal line right here. Here's the equation of the parabola. I'll put it right next to it. How do I figure out where they intersect? Rhymes with substitution. Okay. So take this. That's the only way you can get it. What's going to happen next here? It rhymes with main. Pain. Distribute the minus sign. It's quadratic, so make one side 0. Factor it. Now, some of you have a hard time factoring when there's a lot of factors, yeah? But look, this one's easy, because look, you already know they intersect when x is 2, so doesn't that mean x minus 2 has to be a factor? Because 2 has to be an answer. And then now you can just go, oh, what times x will give me 4x squared? Oh, 4x. What times 2 will, what times negative 2 will give me negative 18 plus 9? But that's only if you think. So there's 2 answers, x equals negative 9/4 or 2. But we already know it intersects at 2. We want the other one, that's this one. Negative 9/4. How do I figure out the y coordinate? You plug it back into either this one or this one. Look, which one looks prettier? I think this one. So what is negative 9/4 squared? 81/16. That's your answer. So one of these is on the test. Where does the tangent line intersect the curve? Or where does the normal line intersect the curve? I don't know. It's just algebra, basically. Okay. Now today we're going to learn how to take shortcuts for computing derivatives, because doing the difference quotient takes a while. Now some of you look, do you guys look for patterns in your answers? Or look at the notes? Okay, this is what we did on last night's arcade. Now, did you guys look at the notes and there's different ways of writing the derivative? Like if you write y prime, that means the derivative of y. dy dx is another way to write the derivative. There are different notations for the derivative. That's because 2 people invented it, right? You got Sir Isaac Newton in England, and then you got Gottfried von Leibniz in Germany. This is Leibniz's notation for the derivative. Okay, let's do the homework. Okay, the first example I did for you on the board was y equal x squared. What was the derivative of that? You guys remember? 2x. And then last night, problem 1a, the derivative of x cubed came out to 3x squared. And then I gave you 1 over x squared. And what was the answer? Negative 2 over x cubed. And then I gave you radical x. That's the one right there. And the answer came out to 1 over 2 root x. Now, do you see a pattern to this? There's a pattern, people. So if you have x to the nth power, to take the derivative, you simply gotta do n x to the n minus 1. In other words, all you have to do, whatever the power is, you put it in front, and then you reduce the power by 1. All you have to be able to do to take the derivative is just be able to subtract 1. So let's see, look, x squared. You put the 2 in the front, reduce the power by 1. X cubed. Put the 3 in the front, reduce the power by 1. Yeah, but what about this one, Mr. Borg? Well, isn't that the same thing as x to the negative 2? Think about that. So all you gotta do is put the negative 2 in the front and reduce the power by 1. What's negative 2 minus 1? Negative 3. Isn't that the same thing as this? Oh, and then this same thing too, Mr. Park. Isn't this like x to the 1/2? So to take the derivative, you just go 1/2 and then subtract 1 from the power. Negative half. Is that the same thing as that? Yes. And that's the shortcut right there. Okay, let's just see if you guys understand. So what if you had x to the 7th power? What's the derivative? 7x to the 6. Oh, that's easy, Mr. Park. That's right, calculus is easy. You're just given all these rules, you follow the rule. You know what the hard part of calculus is? I keep telling you guys, the pre-calculus. Because then you gotta factor, you gotta make number lines, you gotta make piecewise functions, you gotta do trig functions, identities, you gotta work with logarithms and e to the x. That's what students have problems with. Look, the rules for calculus is so easy, it's ridiculous. What about 1 over cube root of x? How do you take the derivative of that? That's the same thing as x to the what power? Negative 1/3. So using the rule, negative 1/3 x to the negative 4/3. It's so easy to take the derivative. And what does the derivative tell you again? The slope of the tangent line. That's all. Okay, what about x? We'll go back to the easy one. What about just x? What's the derivative of x? I'll give you a hint. That's like x to the 1. Using the rule right here, 1x to the 0. But what is x to the 0? So it's just 1. But if you just think about it, it makes sense because what is the graph of y equal x? And look, the slope is always the same. What is the slope? What's the slope of y equal x? 1, because the derivative tells you the slope. And when you have a line, the slope never changes. This is 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, what about 2 then? What's the derivative of 2? I'll give you a hint. No, I'm not going to give you. Just think about it. What does the graph of y equal 2 look like? It's a horizontal line. What is the slope of a horizontal line? 0. The derivative tells you the slope. What's the derivative of 5? 0, because the graph of y equal 5, same thing. It's a horizontal line. The slope is 0. What about negative 3? 0. Oh, so Mr. Park, anytime you have a constant, then the derivative is 0. Wait, let me look. Yeah. Okay, now, if you look in your notes, there are 3 theorems that we're going to use. So the first one, I just taught it to you. If f of x is equal to x to the nth power, then the derivative is equal to nx to the n minus 1, where n is a rational number. Actually, it works with real numbers too, so I'm not going to get into it. Okay, next theorem. If f of x is equal to a constant times a function, then to take the derivative, you simply throw the constant on the side like an unwanted pet, and then you multiply it by the derivative of g.
Wow.
Is that striking a nerve? You throw it on the side like an unwanted pet. Okay, let me demonstrate this. What if you had y equal 5x to the 4th? Okay, isn't 5 a constant? You guys know what a constant is, right? A number. So if you want to take the derivative of this, you throw the 5 on the side like an unwanted pet, and then you take the derivative of this, which is What? Put the 4x cubed, and then now you just multiply the 5 and the 4 and you get 20x cubed. That's a demonstration of that theorem. But can you see that? You can just do it in your head, right? If I put the 4 in the front, 5 times 4 is 20. So you just go from here to here. You don't, I'm just showing you how the theorem works. So let's see if you got it. Y equals 7x to the 8. What's the derivative? 56 x to the. That's how easy calculus is. Okay, one more theorem. If f of x is equal to a sum of two functions, or a difference, the sum or difference, same thing, then to take the derivative, you simply take the derivative of each term. Here's the first term, and there's the second term, and then it's done. Which means it's very easy to take the derivative of polynomials, like this. What if you had y equal 2x cubed plus 3x squared plus 5x plus 7? How do you take the derivative? Well, you just take it term by term. What's the derivative of the first term? 6x squared. What's the derivative of the second term? 6x plus 5 plus, no, 0. More, it's still 0. There you go. See how easy calculus is? Okay, but you know what the hard part is? Okay, tell me when the first derivative is positive. So then what you gotta do is you gotta make a number line for that. Okay? Now, if you can take a first derivative, then you can take what's known as the second derivative. The second derivative is simply the derivative of the first derivative. So what would be the derivative of this? Using the theorems we just learned. 12x to the first plus 6 plus 0. But then if you can take a second derivative, you can take a third derivative. Now, after a while, like on the test, I'm probably going to ask you to find the 2013 derivative. Now, am I going to really write 2013 prime sines? No. So after you get to 2, this is what we normally do. We put a 3 in parentheses. That means the third derivative. Why do I have to put parentheses? Because otherwise, yeah, it looks like y cubed. How can you tell the difference? That's why if you put parentheses, that means the order of the derivative. So what's the third derivative? 12 plus 0. Well then what's the fourth derivative then? 0. Because the derivative of any number is 0. And what's the fifth derivative? What's the derivative of 0? 0 is a constant. 0. What's the ninth derivative? What's the 200th derivative? It's 0. So once you hit the fourth derivative, all the derivatives after that is 0. Because I gave a problem like this once, on the test. I said, y equals, I just made up something like x to the 1000th power and plus some other terms. And then I asked them to find the 2000th derivative. And so a lot of people said, there's no way I'm going to do that, and left it blank. The answer is 0. Can you see why?
Oh, it keeps going down.
Because look, we have a third degree polynomial here. Once you hit the third derivative already, it's a constant, so that means starting from the next one, it's all 0. So over here, that means starting from the 1001st derivative, it's going to be all zeros after that. So now that I told you that, I'm going to give you something else. Okay, now if you look at your notes, there's like a table of derivatives that you need to memorize. Okay, here's one of them right here. The derivative of x to the n is nx to the n minus 1. Okay, but there are 3 more, Mr. Park. Okay, let's do one of them. F of x equals sine x. Okay, after today, we just commit this to memory, but how would you find the derivative of this? Well, there's several things you can do. One is you use the difference quotient from last night, limit h approaches 0, f of x plus h, minus f of x all over h. And then can you see that you're going to have to look for Fred in this one? Yeah, we can do that, but there are better ways. One way is the power series. What's the power series for sine x?
X minus x cubed over 3 factorial.
Mm-hmm. Okay, now see how it, and that's why it's easy to take the derivatives of polynomials, but that's what power series are. They're infinite polynomials, so easy. Okay, so all you gotta do is take the derivative term by term. What's the derivative of the first term? Rhymes with 1. 1 minus. Now, how do you take the derivative of this term? Now, 1 over 3 factorial is a constant, so you throw it on the side like an unwanted pet. And then you multiply it by the derivative of x cubed, which is 3x squared. Oh, but the 3 cancels that 3, so what's going to be left? X squared over 2 factorial. Okay, go to the next term. How do you take the derivative of this? Throw the 1 over 5 factorial on the side like an unwanted pet. And then you take the derivative of that, which is 5x to the 4th. But then the 5's cancel out, and you get? And some of you see it already. Same thing here. Throw this on the side, and then you get 7x to the 6th. The 7's cancel out. X to the 6 over 6 factorial. And then you go, hey, you somebody. That's cosine x. The derivative of sine x is cosine x. And here's another way. This is a lot. Take out your graphing calculator. Do you know your calculator can graph derivatives? Well, you already know it can compute derivatives, right? But it can also graph derivatives. Okay, so we're going to tell our calculator to graph the derivative of sine x. So if you have a TI calculator, then you either do this. So you go y1 equal math 8 and deriv sine x comma x comma. Now, normally we put a number here, but if you put a number here, your calculator is just going to compute the slope at that value of x. If you want your calculator to compute the slope at all the values of x, you just put an x there. Or if you have the newer TI, then you got to type in d over dx of sine x bar x equal x. And if you have a Casio, then you got to type in d over dx, the derivative of sine x. How does it look on the Casio? X equals x. Okay, so if you're with a Casio, you actually have to go to the graph mode. And then you gotta press options to get this derivative thing here. Press options. And hopefully you're in radian mode. So this, what your calculator is doing, it's graphing the derivative of sine x. That's what it's doing. And then, so if you graph it on your calculator, let's do a zoom trig. Zoom trig. So you graph it on your calculator, it should look something like this. And then you go, hey, you somebody, eh? Look at that graph. That's a well-known graph. Don't look at this, look at your calculator.
It's oscillating. Cosine.
Yeah, that's cosine. So your calculator can graph the derivative of any function. All you have to do is like put it right there. Oh boy. Okay, I asked the other class, and let's see if you can do it. What about tan x? So just put a tan x here instead. So your calculator is going to graph the derivative of tangent x. Hey, you somebody! Chai? Close?
Cosine.
Yeah, but secant is hump up, hump down, hump up, hump down, hump up.
Absolute
This one
value
is
of
hump up, 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 hump up.
Cosine. Secant over 2.
I'll just tell you, it's secant squared x. Because it's the secant graph, except you're squaring everything, so all the negative ones become positive. Okay, whatever. Yeah. So this is how you tell your calculator, graph the derivative of something and maybe you recognize it. Okay, let's just do one more. F of x equal e to the x. Now tonight I'm gonna give you specific directions. And by the way, that's the homework over there. That's the last homework of the year. Okay, using power series, compute the derivative of e to the x. Okay, what's the power series of e to the x? 1 plus. Okay, stop pretending like you guys don't know already. Okay, let's take the derivative term by term. What's the derivative of 1? That's the derivative of x. Okay, 1 over 2 factorial, throw on the side like an unwanted pet. And then the derivative of that is 2x, but the 2's cancel and you just get x. Okay, throw the constant on the side like an unwanted pet, so that's going to be 3x squared. So the 3's cancel out. Oh, Mr. Clark, this is beautiful. And then that 4x cubed, the 4's cancel out. Hey, you somebody. That's e to the x. And that's why we study the number e. That's why it's special. Because the derivative of e to the x is e to the x. There's only 2 functions where you take the derivative and you get itself. This is one of them. What's the other one? There's only 2 functions where you take the derivative and you get itself.
Natural log.
No. Come on, it's so obvious.
I to the x.
No! 0! What's the derivative of 0? Wait, they're the same! And look, the derivative of e to the x is e to, that's the only 2, man. But of course, we call this the trivial case. It's not that interesting. But this one is interesting. And that's why the number e is so important in mathematics. That's why when you take calculus next year, almost every single answer has trig functions or e's in it, or natural logs. Oh boy. Okay, what time is it? Okay, last problem, we're done. I'll do a problem almost exactly like your homework. Now, remember that. So, you look at the list. You have to memorize these 4 derivatives now. Otherwise, you cannot do the test. Oh, no, you can. You can just reinvent the wheel, I guess. It's going to take time. It's going to eat up time. What? Okay, f of x is, I think tonight's homework is e to the 2x, right? I'll just do e to the 3x then. Using power series, find the derivative of e to the 3x. Now, a lot of you are thinking, oh, the derivative of e to the box is e to the box. So then just e to the 3x. Except it doesn't work like that. So it's not e to the 3x. So how do we figure it out? We do power series. Okay, what's the power series for this? Quick. E to the box. Here's box. E to the box. 1 plus box plus box squared over 2 factorial plus box cubed over 3 factorial dot dot dot. Simplify each one. 1 plus 3x plus 9x squared over 2 factorial plus 27x cubed over 3 factorial plus dot dot dot. Okay, now take the derivative term by term. What's the derivative of 1? What's the derivative of that?
3.
The derivative, okay, 9 over 2 factorial is an unwanted pet. Yeah. So then you got 2x. The 2's cancel out and you just get 9x. Okay. The derivative of that is 3x squared. The 3's cancel out. So what? 27x squared over 2 factorial. Does that look like a power series? We know. I'll give you a hint, factor out of 3. Hey, you somebody! That's the power series for e to the 3x. So the derivative of e to the 3x is not just e to the 3x, it's e to the 3x times 3. Okay, let's just use that calculator more. Oh, I thought we were going to finish early. I guess that didn't happen. Hey.